In lesson 6, we're going to be talking about midpoint and distance in the coordinate plane. We've already talked about midpoint as being the middle. We know that a midpoint of a segment bisects it. It's right between, it's equidistant to the end points. But if I have a segment graphed on the coordinate plane, you can see here that I have my points plotted, C, D, and I've connected them with my segment. I'm wondering about my midpoint. Well, if we take a look at my x-coordinate here being -3 and my x-coordinate here being 1, my midpoint, I need to be able to find the middle horizontally and also my middle vertically, y-coordinates being 4 and -2. And so what we're going to think about doing is we're actually going to think about taking our x-coordinates, finding the middle, meaning we're actually going to average them to find my middle point. So if I were looking, I'm taking my x-coordinates here, and I can see -3 and 1. I want to average those together, meaning I'm going to add them up and divide by 2. And to find my middle vertically, I'm going to take my y-coordinates, add them up, and divide by 2. And now we're just going to think about simplifying here. -3 plus 1. I'm going to end up with -2/2, which we know is just -1. Over here, I'm going to have 2/2, which is a positive 1. What does that mean? Well, that means that my midpoint is at the coordinate -1, 1. And if we go over on our graph and we find that coordinate point, -1, 1, and we plot that, we can see, yeah, that definitely looks like the middle of that segment. So in the box down below, they are showing us the diagram from our textbook. And that's basically what they're trying to explain, is that midpoint, you're finding the middle of the x's and the middle of the y's. It's a little more confusing. They have because they have the endpoints labeled as x1, y1 and x2, y2. I think about the 1s and the 2s as being like the first point and the second point. And you can see for the formula for midpoint denoted right here, they added the 2 x's and divided by 2, and then added the 2 y's and divided by 2. A lot of times I write it as I did above, where I take and I find my x-coordinate first by taking x1 plus x2 and dividing by 2. And then I find my y-coordinate by taking y1 plus y2 and dividing by 2. And knowing that my midpoint is my point, xy. It is a coordinate point, and so that is how I'm going to write it. And again, the idea of midpoint, I'm a lot of times thinking of average. Averaging my x's and then averaging my y's. So when I come down here to example A, I'm wanting to find the midpoint of my segment EF. By using my formula, I don't have to plot my points and graph it out. I can if I wanted a visual, sometimes that's helpful, but I am going to take my point E, -2, 3. This is going to be my x1 and my y1, and F is going to be my x2 and my y2. So the first thing I'm going to do is I'm going to find my x-coordinate, averaging my x's. I'm going to take -2 plus 5 and divide by 2. I can see I'm going to have 3/2. And then I'm going to average my y's. Well, my y-coordinates are 3 and -3. Well, 3 plus -3 is 0. And 0 over 2 is just 0. What does that mean? Well, that means that my midpoint is at the point 3 over 2, comma, 0. 3 over 2 is 1.5. Sometimes you just want to kind of see if that makes sense. Now, if we plotted my segment EF and we visualize the point -1, 0, we should know that that's going to fall on your segment right in the middle. Question 2 is just slightly different because in question 2 they tell me that M is the midpoint of AB. A has the coordinates 3, 5. M has the coordinates 6, 1. Find the coordinates of B. So in this case, I have my x1, y1. But when they give me the coordinates of M, that is my midpoint. To me, that's kind of like the answer. I need the coordinates of B, which is my x2 and my y2. How would I do that? Well, if they give me my coordinates 6, 1, I'm going to think about that as my x and my y. 6 is my x coordinate. That is what they got when they took 3 plus x2 and divided by 2. So I'm simply going to think about what value would make that true. Y, well, my y coordinate is 1. That is what they got when taking 5 plus y2 and dividing by 2. Now, some people can solve this just by visualizing the segment and kind of reasoning through. If I needed to solve it algebraically, I would want to get rid of my fraction. So I would first start by multiplying both sides by 2. And I can see that we're going to end up here with 12 equaling 3 plus x2. Or finding out when we subtract that 9 is my x2 value. Same thing over here. I'm going to get rid of my fraction. I have 2 equal to 5 plus y2. Subtract 5 on both sides, and we find out that y2 is a -3. What does that mean? Well, the coordinates for my point B are at 9, -3. Now, if you compare A and M, I can see for my x values that 3 and 6 are 3 units away. And so when I take my midpoint and my other endpoint, they should also be 3 units away because I am right in the middle. Likewise, my 2y here, 5 to 1 is 4 units away. 1 to -3 is also 4 units away. Equidistant to my endpoints. If you go ahead and flip your paper over to the back side, again I have my same points CD, so I'm going to go ahead and plot those. This time, I'm asking you to think about finding the length of that segment. We just found the midpoint to be -1, 1, but what about the length? Now, I can simply count boxes going diagonally because those are not exactly 1 unit. But because this is graphed on the coordinate plane, we can think about forming a triangle here. And I have a right triangle. I'm looking for this length. Well, if I take a look, the legs of my triangle, 1, 2, 3, 4 boxes means this is 4 units horizontally, and 1, 2, 3, 4, 5, 6 boxes means that this is 6 units horizontally. We know with a right triangle, we can go ahead and use the Pythagorean theorem. So we can say that 4 squared plus 6 squared is equal to x squared. And we can find that length simply by simplifying. or solving for x. 4 squared, 6 squared. Well, we'll add those together. We're going to find out that 52 is x squared, meaning that x is going to be the square root of 52. Now we know that's not a perfect square, so it's going to come out as a decimal. We're just simply going to round that to the 10th, and when you punch that in your calculator, you're going to find that it comes out to about 7.2 units. What does that mean? Well, that means my length of segment CD is about 7.2. Now, if you take a look, we happen to notice that my 4 boxes here, my length of 4, well, I could also think about that as my x coordinates. If I would have taken -3 minus 1, the absolute value of that would have given me my 4. My y coordinates, 4 and -2, well, thinking about finding that length, it would have given me my 6. Okay, we're going to come back to that, but a reminder, Pythagorean theorem, as we said above, a squared plus b squared equals to c squared. We can use it with right triangles, and we know that our c has to be our hypotenuse, or the longest side of my triangle. Sides A and B can be interchanged, but C has to be the hypotenuse. The distance formula. Well, the distance formula is derived from the Pythagorean theorem. This is the way it's going to look in your book. You're going to have D equals, and they're going to have this big square root sign. If my endpoints are x1, y1, x2, y2, this is how the formula is going to look. They're going to take x1 minus x2 quantity squared plus y1 minus y2 quantity squared. This formula is derived from my Pythagorean theorem. Really, this part here is my a squared, and this part here is my b squared. And then at the end of the Pythagorean theorem, the very last thing that you do is you take the square root of it. And that's why we have this big square root sign there, by large radical. So the distance formula allows me to find the length without having to graph on the coordinate plane. If I look at example B, we're going to look at doing this both ways. My endpoints are -9, -4, and 1, 5. Well, if I didn't want to graph it, I could think about using my distance formula. Here's going to be my x1, y1. Here is my x2, y2. I'm simply going to substitute my values into my equation. First is the x's, -9 minus 1 quantity squared, plus -4 minus 5 quantity squared. A lot of times we run into trouble when we're trying to put this all into our calculator. So I just suggest doing some simplifying first. We know that if we're following the order of operations, the very first thing is the parentheses. So I'm going to take a look at -9 minus 1. Well, -9, add the opposite. We see, oh, I get -10. And -4, add the opposite, I would have a -9. Now we do exponents. Well, if you take -10 and you square it, we know we should get a positive answer. But a lot of times on a calculator, students will end up with a negative. And that is because they don't put the you need to make sure you put your parentheses. If you don't put them in there, your calculator will give you a negative 100. Okay? So, squaring, I would end up with 100 plus 81, both positive values, or finding that my distance is the square root of 181. We can round that to the nearest tenth, and when we put that in our calculator, we're going to find that it comes out to approximately 13.5 units. So here I was able to find my length, not having to graph it, but simply just substituting my points or my endpoints in. Now, if I wanted to, I could have used the Pythagorean theorem. I could go ahead and graph my negative 9, negative 4, and 1, 5. And just like before, we could look at forming our right triangle. If I would go ahead and counting horizontally all of my boxes, I would end up finding that I have 10 units horizontally. Counting my boxes vertically, I would find that I would have 9. And again, we're solving for x. Well, you can see here my 9 and my 10. 10 squared plus 9 squared equal to x squared. I am going to end up with the square root of 181. So either way, you should get the same answer. Again, if you want to see more examples, you can check out the online videos available through our online textbook. Otherwise, please stop in and see me for more examples or if you have questions.